So let's discuss um, what we're doing here. And the first thing we need to make sure you're aware of is that any mole of gas occupies the same volume. And I tried to prove this on one of my stoichiometry tests, and you should have learned this with the PV equals nRT. So basically, what that means is since we're using a battery to break water into its component parts, hydrogen and oxygen, the space that's being used by the hydrogen is twice as much as the space used by the oxygen because there's twice as much hydrogen as there is oxygen in water. So it's relative. Likewise, if we fill a balloon with, say, carbon dioxide, and then we fill a balloon of the exact same size with helium, because they're the same size, they have the same moles in each. And because carbon dioxide then weighs more per atom than helium, this would be more dense. Carbon dioxide weighs 44 grams per mole, and helium weighs 4 grams per mole. So this would be less dense than that. And this would fall, which is what you saw when we did the baking soda lab and we filled up balloons with carbon dioxide, and this would rise. All right, moving on. So here's sort of the trick of this unit. You have to know, when do I use P1V1 over T1 equals P2V2 over T2, and when do I use PV equals nRT? And it really boils down to, do you see the word moles or grams? If you do, then it's this one. If you don't, then it's the P1V1 over T1. Another indicator is that you're looking for multiple pressures or multiple volumes or multiple temperatures, right? This only has one place for a temperature, one place for a volume, and one place for a pressure. This has two places for every one of those. So this will be talking about multiples, and this one won't. Basically, the reason we're teaching you this is because as a human being, there will be a time when you have a screwdriver and you have a wrench, and every now and again you're going to need to use the wrench, and every now and again you're going to need to use a screwdriver, and you got to figure out which one works in that situation. All right, so let's explore. Here's a sample. It says the word grams, and that tells you PV equals nRT, hopefully. All right. It didn't, if it says grams or moles, the only place to really put that is that N. So it's looking for the N here. Let's break everything else down. This is our volume. So our volume is 347 milliliters. And hopefully you realize that in this unit, it's safest to put everything in liters. And that's because of the units of R. So we need to go Father, Son, Holy Spirit. And that becomes 0.347 liters. The pressure is here, the 110 kPa. You know that from the units of the pressure, kPa. The temperature is currently in Celsius. We need that to be in Kelvin, right? That's a big stickler in this unit. So we're going to add 273, and we're going to get 323 Kelvin. And then the R we're going to use, because this is kPa, we're going to need that R that deals with kPa. And that is, hold on a second, 8.3. Wait, is it? Is it 8? Wait, hold on a second. Internet, you've let me down. All right, so the R that we use is with kPa 8.314 is the one we use. So this is 8.314. That's kPa liters per mole Kelvin. So that's the one we have to use. So that's the key to when you do these problems, is you have to know when to use these things. All right. So then we just multiply all that out. So we got 110 times 3.347, because that has to be in liters. That's going to equal our N, which we don't know. R is 8.314, and our T is 323. When we do that, we get 110 times 0.347 is 38.17. And And then 8.314 times 323 is 2685. And then n is what we're looking for. So we want to isolate that n, so we got to divide both sides by 2685. And remember, n is going to give you our moles. So when we solve for that, 38.17 divided by 2685, we get 0.0142. And those are the moles. And this asks for grams. So grams to moles from moles. So if we have 0.0142 moles, 0.0142 moles, you remember when we were betting on horses that you make it a bigger number when you want grams. So 1 mole of nitrogen, which if you go to the periodic table, nitrogen is number 7 and it weighs 14, and nitrogen is a diatomic, so that would be 28 grams of 1 mole. So 0.0142 times 28, the answer here is 0.398 grams or 398 milligrams. There's your answer. All right. So when you're doing this assessment this week, I need you to show your work. And if you're showing a lot of work and you're using the right R and you're using the right equation and all that, you're going to be in good shape. So let's take a look here. We got a temperature, a volume, two volumes. So hopefully that's indicating to you that we need a P1, V1, T1, and we need a P2, V2, T2. So let's figure that out. So our P1, is there any pressure in it? There is no pressure mentioned. It does have a temperature. So our T1, we'll call it 20 degrees, and that has to be in Kelvin. So that becomes 293 Kelvin. We added 273 to that. Volume of 2.3 liters. So this is 2.3 liters. We have what temperature? So T2 is the big question mark. So this is our question mark. Our volume 2 is right here, 6.5 liters. And then our P2, again, since P2 and P1 are not mentioned, you can set them both equal to 1, or you can drop them out of the equation, whichever one makes you more comfortable. Oops, back up. So this equals 1. All right. So V1 is, should have been red. So 2.3 divided by T1, which is 293, is equal to V2, which is 6.5. 6.5 divided by X, which is what we're looking for. So here you can cross multiply if you want. You can multiply the X over there and then divide by that, however you want to do this. 2.3 divided by 293 is going to give me 0.00784. So in red, 0.00784 is equal to 6.5 over X. And then to get that X out of there, I multiplied here and I multiplied here. And basically I get 0.00784 equals X equals 65. So then I need to divide both sides by 0.00784 to isolate that X. And what you get is X is equal to 6.5 divided by 0.00784, 829. And the units of that are, because it's temperature, are Kelvin. All right, this one, ammonia occupies, we have a number here. Pressure, we have a pressure. What volume is looking for? At standard pressure. So it says the word pressure twice. It says 2 volumes. So this one will be, hopefully you realize, P1 V1 over T1 equals P2 V2 over T2. So we're going to need to set that up. All right, so let's figure this out. This first one, 675 mils, is a volume. So our V1 equals 675 milliliters, which you can keep like this. I suggest you always convert to liters. So there it is in liters. The pressure is 450 millimeters of mercury. Okay, there's no mention of temperature, so T1 is either going to be 1, or you can just say, just knock it out. Your P2, let's get into the other ones. Oh, that's why that happens. P2 is standard, so you will have that chart, or you can use that chart. For millimeters of mercury, that's 760 millimeters of mercury is standard. And then V2 is what we're looking for. And then T2 is 1 again. So when you plug all this in, you're going to get 450 times 0.675. So 450 is your pressure, 0.675 is your volume. We've dropped out our temperature and made it equal to 1, and that's going to equal 760 times x, because that's what we're looking for. So then to isolate that x, we got to divide the 760 over there. So your x is going to equal 450 times 0.675 and divided by 760. And you get 0.3996, or basically 0.4. So x equals 0.40. And those units are going to be liters, because that's our volume, right? So 0.40 liters. All right, moving on. What volume will, here's the big keyword. We got the big keyword here, and the keyword is moles. So this is a PV equals nRT problem. All right, at STP, so standard temperature is 273, and standard pressure can be whatever we want. Now we can choose whatever we want. I like to use as my standard pressure 1 atmosphere, because then it's just multiplying 1, and that makes it easy. You could use 760, just make sure your R agrees with whatever pressure you take. Volume is what we're looking for, so volume is our question mark. We have the moles, and it's equal to 3.2. And R, because we used atmosphere, our R is going to be the 0.0821, right? Isn't that what that is? 0.082, yeah. All right. So we just plug all that in now. So we got the P is 1 atmosphere. Our V is question mark. Our N is 3.2. Our R is 0.0821. And our T is 273. And we're going to solve for V. So basically we just have to multiply 3.2 times 0.0821 times 273. And that's 71.7. So V equals 71.7. And the units of that are volumes. So that has to be liters. All right. There you go. Is that it, hopefully? Thank God. All right. There you go. When to use one, when to use the other. I'll make one other quick thing about the other thing I'm going to have you do.